Everyone is talking about Gaussian splatting, and most people think that it is just one tool. So they go over Google and ask Gemini, what can I use to create a Gaussian splat? But the reality is, Gaussian splatting is actually a pipeline, and you can have several tools that help you at each step of this pipeline. In this video, we will go over it. I'm Irenoyd, and I create content about emerging technologies like Gaussian splatting, but also cool technologies like extended reality. So if you are into that, subscribe and follow for more. If you don't know what is Gaussian splatting, I already created a video about it. You will find it in the description of this video or at the end of this video. In the description of this video, you will also find all the tools that I'm mentioning today and more. Just a quick reminder that at any point of this video, you can jump ahead. You just click on the timeline below to go to the next chapter. Let's get started. So at the time of this video, we have 5 categories of tools. We have full pipeline tools, which are all-in-one environments. We have training engines. We have capture tools, no-code desktop tools, and editing and viewing tools. Now let's get into each one of them. I will give you some example and explain you what they are, what they actually include, and when to use them. First of all, full pipeline tools. These are end-to-end systems where you can train splats, inspect the results, edit scenes, and manage workflows. They combine multiple layers into one tool. So instead of chaining tools, everything happens in one place. And they're often built for advanced users or teams. Some examples are Lightfield Studio and Nerf Studio. What are the limitations of these tools? Well, first of all, they might be complex to set up because you need to install additional PyTorch, CUDA, dependencies in Python, and so on. There is also some capture fragility. So that depends heavily on how perfect the input footage is. So if you have bad lighting, there will be noisy reconstructions. If you have motion blur, there will be estimation failures, and so on. Of course, even if it's a full pipeline, you might have to choose the right model, you have to adjust some configurations, manage camera poses, and handling manually some failures. So there are still some aspects that are not fully automated. There might be limitations in the editing of the meshes, of the lighting, material, and so on. Depending on the tool you choose, you might have a very slow processing step. So very large splat scenes might slow down your process, and there may be a training which is slow. But in terms of advantages, you have almost everything in one tool. It might be hard for beginners, but for advanced users, this is a plus. And even though there are some hookups here and there, you can manage to use them effectively. Now, training engines. These are algorithmic cores that turns, for example, images into Gaussian splats. Some examples are G-splats, original 3D GS, instant splats. If you don't have a user interface, you have no capture, you have no editing. It just focuses on uploading some images, for example, and directly turning them into Gaussian splats. So they optimize Gaussian parameters, they reconstruct the scenes from images, but also videos in some cases. And the output will be a file in the format of .splat or .ply. You can use them when you want custom pipelines, integration into Unity or Unreal, and maximum performance or research flexibility. Then we have capture tools. In these tools, basically you can capture and they process it for you. Some example can be Polycam or Scaniverse. You probably saw many videos about it on my YouTube channel, Loom AI, and Kiri Engine. For example, I created this Gaussian splat with Loom AI. I downloaded the application on my mobile phone and I scanned this bot, and then I could retrieve it from the browser. I can navigate it with my mouse and I can also download it in different file formats. With these tools, you can capture images and videos. They run the training automatically in the backend and they output ready-to-view Gaussian splats. So when should you use them? When you want fast content creation, you're not a technical user or anyway an advanced user, and you're interested in a result right away. There are some limitations. For example, the Gaussian splat might not be the best and might have low resolution depth, You might not be able to relight anything or edit what is the result, and you cannot play around with some hyperparameters. There are also no-code desktop tools, which usually sits between the engine and the capture tools. So in these tools, you have a desktop application with a user interface, so it's user-friendly. And if you are non-technical, you might like them more. They still require you to provide the images as input, but you have more control than mobile tools, like for example, Scaniverse or Kiri Engine. You can import your images or videos, you can run Gaussian splat training and export the results. One example is PostShot. So when is best to use them? When you don't want to code anything, you want local processing, and you want control over the Gaussian splatting training. Last but not least, we have the editing and viewing tools. These are tools to clean, optimize, and deliver splats. Some examples are Supersplat, browser viewers, and also Blender add-ons. They don't create the splats, they just refine and present them. So you already come with a well-captured splat, and you upload this splat to the platform, and they can remove artifacts like floaters, something that is not part of the main object of the splat, and you want to just cut it out. You want to optimize performance, or you just want to display the splat. So these are the best for visualizing the splat and preparing assets, for example, for clients demo or web browsing, sharing experiences in general. So these are many tools, but how do they connect to each other? So usually the workflow is that you capture the place or the object you want to capture. Then you train the Gaussian splat, you edit it, and you deliver the visualization of the Gaussian splat that can be on the browser or in virtual reality. Now, with the no-code desktop tools, you have a simplified training, and you basically cover the capturing and training of the Gaussian splat. Instead, with the full pipeline tools, you have everything combined. In terms of strategic differences, in the capture tools, you want to use them for speed and demos. Training engines are good for control and scalability. Editing tools are good for delivering quality. And full pipeline tools are optimized for team productivity. In enterprise settings, you usually combine the capturing, the training, and the optimization, rather than relying on one tool alone. And at this point, you're wondering, how can I choose them? Well, it pretty much depends also on what your goal is. If your goal is virtual reality or interactive 3D experiences, then maybe you want to use Nerf Studio plus Polycam for the capture, and then you switch to Blender or Unity. If your goal is to have a fast demo or a proof of concept, you might focus on Scaniverse or Polycam. If your goal is full control and integration into third-party apps like Unity or artificial intelligence pipelines, then you might want to focus on GS Splat and Nerf Studio. If you want high-end research and development and innovation work, you might want to focus on Nerf Studio or Instant Splat. And if you have a non-technical team or you want to use them for business, then Polycam or PostShots are the best tools. Let me also specify that these tools are improving day by day, so some limitation presented in this video might be not available anymore in the future. I will make more content about Gaussian splatting, so stay tuned for more.